Good day, guys. Welcome back to the RPA tutorial, specifically the exam questions, sort of focused ones. Again, key question to start off, make sure you know what I'm talking about for the first part. As I go into the second question, it'll be a little bit more detail, a little bit more sort of experience, if you will. But make sure you stick around for the first one. The second one's optional. All right, so let's have a look. This is looking at the ruler drop, okay? Looking at the homeostasis questions, homeostasis RPA here. So let's have a go. So some students investigated the effects of caffeine on a person's reaction time, just like we did. The students used the following steps. One student held a ruler just above the second person's hand, as shown in diagram 2. All right, even if it's not the best way to do it, there are some mistakes with how they're doing that, but that's okay. We'll deal with it. The students let go of the ruler, and the second student caught it as soon as possible, shown in diagram 3. The student repeated the experiment 7 more times. The student catching the ruler then drank a cup of strong coffee, which contains caffeine. 15 minutes later, after drinking the coffee, the students repeated the investigation. Okay, one student. Yeah, okay, all right, so here we go. Table 1, distance fell before drinking coffee, distance after drinking coffee. Okay, the student used the reading on the ruler as a measure of reaction time. What do the results show about the effect of caffeine on reaction time? Okay, so the key part here is it's asked you about reaction time. So this is the distance it was caught in centimeters. And so before drinking coffee, it fell 18.4 centimeters on average before it was caught. After drinking coffee, it only fell 12.4 centimeters before it was caught. Fell, so it should be a bit like that, right? Okay, which means in this case, when it was a smaller number, the person caught it quicker. And if the person caught it quicker, they were faster reaction times. So what do the results show? The caffeine seemed to speed up reaction time. It made your reactions quicker. It made you catch the ruler much faster. Jobs are done it. All right, so here we go. Look carefully at all the data from Table 1 and Table 2. This one's a little bit more tricky. Using the data from Table 1 and Table 2, give one reason why a scientist may not accept your conclusion to be I. All right, let's have a look here. So why not? All right, so one of the things you can see is that there's a lot of sort of like a lot of this data could sort of fit in different places. 13's above 12, that they overlap a lot. They've got very, very similar numbers overall, right? And so you could say something like the data seems to overlap a lot. Data seems to overlap a lot, okay? Because the numbers are very similar, all right? Very, very similar numbers. So the overlap could be it. The other thing is that the student, it's only done with one student, okay? Only done with one or a few students, right? Okay, and that, it means we can't accept that broad statement. If we've only done it to one person, right, we need a lot more people in order to make fair conclusions. All right, so here we go. So how could the student improve their investigation? So just two ways, effectively, more students. More students or people involved, right? More students / increase what we call sample size, right? Increase sample size or the number of people. Sample size. There we go. Suggestion number 2. What did they drink? Okay, so the student drank a cup of strong coffee. Okay, so we could actually perhaps measure out concentration. We could give specific concentrations of caffeine instead of just a cup of strong coffee where one cup might be stronger than another. Or we could control the volume of caffeine that they ingest as well. A concentration and a volume, right? So I'd say probably they're the big two. More students, and make sure you have the same concentration of coffee scientifically as well, right? So you don't get different amounts of caffeine in each coffee. And that's the key question, guys. Making sure that you can step through and understand what's going on there. I'll run you through the next one right now, guys. So hopefully you'll stick around for the thrill of it. Here we go. So two students compare their reactions using a ruler. This is the method used. Student A sits with his elbow on the table, or her elbow on the table. Student B holds the ruler so that the bottom of the ruler is level with the top of the student's thumb. Student B drops the ruler. Student A catches the ruler, records the drop distance. Repeat steps 1 to 5 4 more times. Repeat the whole experiment with student A, and so switch it around, basically. Pretty much exactly what we did. Exactly what we've done in the RPA. Right. Both students are right-handed. The students are testing their hypotheses. The drop distance of the ruler is smaller when a right-handed person uses their right hand to catch the ruler. Student A uses his right hand to catch the ruler. Student B uses her left hand to catch the ruler. Okay. Complete the sentence. Use the answer from the box. The drop distance was the control, dependent, or independent variable. Well, the drop distance is the variable that we're measuring, which is going to be our dependent variable. Okay, so the dependent variable is what we measure. The independent variable is the variable that we change. So in this case, the independent variable would be whether they're right or left, or handedness, basically, the hand they use. All right, the table below shows the students' results. Test 1, 2, 3, 4, 5. Student A. Yeah. Student B. Okay. All right. Figure 2 shows student B test result 2. I was wondering about that gap. Okay, here we go. So figure 2. Use figure 2 to complete the missing result for test 2. Write the answer in the table above. Okay, so I'm sorry, it's a little bit blurry because of my screen capture here. Just got to make it a little bit hard to read. Sorry, guys. I should have thought of that. I'm pretty sure that's 18 and that's 19. So if this is 18, then that's going to be 18.5, which means that's going to be 19. So if that's 18, that's 17.5, and therefore that should be 17. It's hard when I can't see it properly, sorry guys, but I'm pretty sure that's 17 centimeters, okay, or 17.0. I'll double check when I can get a higher quality image. Here we go. What is the resolution of the ruler that the student used? Tick one box. Okay, so what is the resolution? It's looking at what is the smallest distance we can tell between 2 points, and that smallest gap between these is 0.5. So the resolution of this ruler is going to be 0.5 centimeters. It is the smallest gap, right? Because this is 22 and the smallest gap between these points is 0.5 centimeter. So that is going to be our resolution, right? Okay. So let's have a look at this. One of the results in the table is anomalous. Identify the anomalous result. Give the reason why you chose your answer. Okay, so let's have a look at this table and let's pick the anomaly. All right, look at this bad boy. It's sticking out like a sore thumb right there. Okay, what you've got there is you've got someone who's getting 17, 15, 15, 17, and then all of a sudden there's one that's 5 higher than even the slowest reaction just there. So it's basically 30%, 33% higher than any of the other ones. So 23.5. Identify the anomalous result was 23.5 for person A, wasn't it? For student A. For student A. Why did I choose this result? Because it was much higher than all the others. Much higher by 5 centimeters than all the others. All right. And because it was much higher than all of these other results, it didn't fit the pattern. And if it didn't fit the pattern, it's what we call an anomalous result. Whereas you look here, 19, 21, 19.5, 20, 17, they're all pretty close together. Okay, and because of that, there weren't any anomalous ones there. All right, students are testing the hypothesis. This drop distance of the ruler is smaller when a right-handed person uses their right hand to catch the ruler. The results of the table are not a good test of the hypothesis analysis. And what is the reason why? The drop distances are very variable. The drop distance for student A is sometimes bigger than the drop distance for student B. The results are for the left and right hands of different people, or the drop distance are not measured accurately. And so the fact that they've used student A was catching it with their right hand, and student B, they changed students and then caught with their left hand. You don't know, it could be differences in individuals that's causing the problem, not necessarily the handedness, and therefore that's not a fair statement. So it's basically because they did it with different students, and because they used different students for right and left-handed, that's not a good experiment. A better experiment would be to have student A catch it 10 times with their right hand, and then student A again catches it 10 times, but this time they use their left hand, because then you know on average where the student was with their right hand, and you can compare those numbers together fairly. All right, a much better way of conducting that experiment. Again, trying to tease out these experimental design sort of questions and these analysis, because they do come up fairly often. Most RPA questions will have some sort of experimental thinking or process that you have to step through. So the more we step through and practice it or see my process of thinking, hopefully the easier it will be for you. All right, guys, I hope this helped, and I'll catch you later.